This is Chris Rella here. Today we're going to talk about prime time. This is Unit 5, Lesson 2. All right, so the objectives of this particular lesson are to distinguish between prime and composite numbers. Prime and composite numbers. Now, you're going to need all that factoring stuff that we did last time to help you figure out the difference between prime and composite, okay? And then we're going to identify the factors of a composite number. All right, keywords are composite number, prime number, and prime factorization. I actually really like prime factorization. It's kind of cool. Anyways, all right, so prime versus composite. So how do we know the difference between a prime number and a composite number? Well, a prime number is one that only has two factors. Now remember, we talked about factors in the last lesson. We could go down the line using our divisibility rules. And if more than one rule applied, it's a composite number. If I can only multiply the number times itself, it's a prime number. So let's look at some examples. Well, these are composite numbers. I have 56. Okay, hide this little guy down here. So with 56 going down the line, I've got 1 times 56, 2 times 28, 4 times 14, and 7 times 8. There's definitely more than one, right? What about 32? 32, we had 1 times 32, 2 times 16, 4 times 8. Again, more than one. We had 51. 51 is a new one. Wait, what? 50, it's an odd number, right? So it's automatically prime, right? No. Just because it's odd does not mean it is prime. Let me say it again. Just because it's just because it's odd does not mean it is prime. In this case, I have 1 times 51 and 3 times 17. Ooh, bet you didn't know that one, right? How about 39? Again, it is a composite number because not only can I do 1 times 39, I can do 3 times 13. Okay? So just because a number is odd does not mean it is prime. All right, so what does it mean when it's prime? Well, in the case of number 5, I have 1 times 5. That's it. That's all I can do. 1 times 5. But 37. I can go through my list of divisibility rules. 1, 2, not even. 3, nope, that's 10. But what it comes down to is 1 times 37. So 37 is a prime number. What about 59? Yeah, 59 is a good number. It's big. And wait, no, that's it. Just 1 times 59. Okay. And how about 73? Yeah, 1 times 73 and no, not 2. 7 and 3 are 10. Can't do that. Can't do 6. Can't do 5. Yeah, that's it. That's all I can do. 1 times 73. Okay. So how is that going to help me? Well, when we're doing prime factorization is when it's going to help you. And this is where we kind of see the nitty-gritty, the bones, the dirt bottom of our factorization. This is the lowest it can go. So there's a song that was like, "Hello, can you go?" I think it was from the 70s, 80s, I don't know. Anyway, so prime factorization takes us to the lowest point that we can. All right, so let's start with 56. It's been a good number for us, right? All right, so I've got factors of 56 are 1 times 56, 2 times 28, 4 times 14, and 7 times 8. So I'm just going to pick one, and I'm going to pick 7 times 8. All right, so my question is, are either of these two numbers prime? As a matter of fact, yes, 7 is prime. We're going to circle 7 and say, okay, thanks, we'll be back. All right, now what about 8? Well, factors of 8, 1 times 8, 2 times 4. So no, it's not prime. So let's break this down. Let's go 2 times 4. Because when we're doing this prime factorization, if one set of factors is 1 times 8 and the other set of factors is 2 times 4, we don't want to use the 1, because if we have a number 1 and then a number, we're just we got to keep going. So it doesn't do any good to use a number like that. We have to keep breaking it down farther and farther. We don't want to use anything with 1 while we're doing our prime factorization. All right, so let's look at 2 and 4. Well, 2 is prime. In fact, 2 is the only prime number that's even. Did you know that? 2 is the only prime number that's even, because all we have is 1 times 2. Okay, so we'll circle that. And then we'll look at 4. I only got 1 times 4. Don't want to use that. What about 2 times 2? Yeah, we can use 2 times 2. And we already know that 2 is prime, so we're going to circle up both of those guys. All right, now off to the right here, we're going to rewrite the prime factorization for this particular number. We know it starts with 7, then it goes times 2, times 2, times 2, okay? And we can rewrite that as 7 times 2 to the third power. Okay, so if you look at it, we have 3 2's. I can change that into an exponential number, an exponent of 2 to the third power. So instead of saying 7 times 2 times 2 times 2, I can say 7 times 2 to the third power. All right, let's try another one. Oh yeah, actually, I'm sticking with 56. Let's try a different set of numbers, though. Let's try 2 times 28. All right, so 2 times 28. Well, I know 2 is prime, right? Give that bad boy a circle. Now I'm going to move over to 28. Well, what are the factors of 28? 1 times 28, 2 times 14, 4 times 7. I'll go with 2 times 14. Okay, I know 2 is prime, so I'm going to circle that. And then I have to go to 14. I've got 1 times 14 and 2 times 7. Well, I got to use 2 times 7 this time. So 2 times 7, 2 is prime, so we'll circle that up. But hey, 7 is prime too. So let's circle them both up. All right. Now, did I get the same prime factorization as I did last time? Well, I had 7 times 2 times 2 times 2, right? Gave me 7 times 2 to the third power. So I did get the very same, right? All right, so this is how we break it down for prime factorization. Let's do another one. Let's do 36. Well, the factors of 36, are 1 times 36, 2 times 18, and 3 times 12. 4 times 9 is also a factor of 36. And 6 times 6. Boy, I keep coming up with new ones. Actually, let's go back, okay? No, let's go forward. So let's pick a number here. Let's go 4 times 9. All right, let's go 4 times 9. So let's look at 4 and 9. Are either one of these numbers prime numbers? No. So can we break them down? Well, for 4, I've got 1 times 4 and 2 times 2. So that's the only other set of factors that 4 has. So I'm going to go ahead and break that down. 2 times 2, both 2's are prime, and I'm going to circle both of them. And then we have 9. And we can break 9 down as 1 times 9 and 3 times 3. That's the only other thing that we've got, right? So we're going to break down 3 times 3, which means 3 and 3 are both prime. So now let's go ahead and rewrite this as a prime factorization. So we have 2 times 2 times 3 times 3. And so when we go ahead and combine that and use our exponent skills, we're going to have 2 to the second power times 3 to the second power. All right, that's it for this particular lesson. If you have any questions, please don't hesitate to give me a call. My phone number is area code 501-386-3366. Y'all have a great day. Bye-bye.